So today we're talking about simplifying rational expressions. And so what we mean by a rational expression is an expression that can be written in the form of a fraction with a numerator and a denominator. Now these numerators and denominators are going to be algebraic expressions. And so in order to simplify these rational expressions, we basically just factor everything that we can, factor the numerator, factor the denominator, and then cancel whatever you can and leave your answer in factored form if there are extra factors. So on number 1, the numerator can be factored into a difference of squares, 1 plus x times 1 minus x. The denominator is x minus 1. So now when we look at those factors, I notice that I have a 1 minus x and an x minus 1, which those do not exactly match. But if I were to factor a negative 1 out of one of them, then they would. So I will factor out a negative 1, which will change the numerator to a negative 1 times x minus 1. Now when we look at canceling, I can cancel the x minus 1 from the denominator, the x minus 1 from the numerator, and what I'm left with is a negative 1 times 1 plus x all over 1. And so rewriting that, simplifying it, I'm going to go ahead and distribute the negative 1, and I get negative x minus 1. For number 2, notice that we've already got factors separated out. Okay, it's already in factored form, so we just need to find factors that match that we can simplify. So when I look at this, I see that there's an x squared plus 4 and an x squared plus 4, one on top, one on bottom, one in the numerator, one in the denominator, so those cancel. Looking at my numeric values, I've got a 2 and an 8, so I can divide 2 into 2 one time, 2 goes into 8 4 times. Then I notice that there's an a squared in the numerator and an a in the denominator. So I can cancel 1a from the denominator, 1a from the numerator, which leaves another a left over. And that's all that is there that we can cancel. So what we do is gather up anything that's left over. So in the numerator there's an a, and there's a b minus 3, so a times b minus 3. In the denominator there's a 4, a b squared, and an a minus 2. So 4b squared times a minus 2. And we want to leave our answers in factored form. So at that point you're finished. As long as there are no more than one of each of these variables, the a and the b, your numeric values have been simplified like you would a fraction, and there are no other factors that are in common on the numerator and denominator. For number 3, what we have are two rational expressions that are being multiplied, and so the same process applies. We want to get everything factored, and then as you know with fractions, when you multiply fractions you can cross reduce, and so that's the principle that we're going to use here to simplify this expression. So starting with the numerator of the first fraction, I'm going to factor it into a 2x and an x, a plus 1 and a plus 2. In the denominator, that's a difference of squares, so 2x plus 1 times 2x minus 1. I'm multiplying that times the next fraction. When I factor this numerator, I get a 2x and an x. I get a minus 1 and a plus 1. And then its denominator is going to be an x plus 2 and an x minus 1. So once I have everything in factored form, I look for factors in the numerator and denominator that match, and I'm going to cancel them. So here's a 2x plus 1 and a 2x plus 1. I have an x plus 2 and an x plus 2. And then I've got a 2x minus 1 and a 2x plus 1. So all that's left after all that canceling is an x plus 1 in the numerator and an x minus 1 in the denominator. Number 4 is similar, except for this time we're dividing. So we use the principle that says when you're dividing fractions, you keep the numerator as it is, the first fraction as it is, change to multiply, and change the second fraction to its reciprocal. So once I've changed the division to multiplication, now I'm going to go back and work the same way I did on number 3. So the numerator of the left term won't factor. I've got a difference of squares in the first denominator, y plus 2 and a y minus 2. On the right-hand side, I'm going to factor the numerator into a y and a y, a plus 2 and a plus 3. The denominator is a y and a y, a minus 4 and a plus 1. So now I'll go through the process of finding factors that match on top and bottom that I can cancel. So a y plus 2 and a y plus 2. A y minus 4 and a y minus 4. And that's all that will match that we can cancel. I'm left with a y plus 3 in the numerator, and then the denominator a y minus 2 times a y plus 1. Once again, leave your answer in factored form. Do not multiply it all back together. We want to leave it in factored form. Okay, number 5, we want to look for any common factors that we can factor out, and I'm seeing these x minus 2's all over the place. So in the numerator, I've got an x minus 2 squared, and I've got a 3 times x minus 2. So I'm going to factor out one of the x minus 2's, which leaves me with an x minus 2 plus 3. In the denominator, I've got x minus 2 cubed. So, looking for things to cancel, I've got an x minus 2 in the numerator, and I've got 3 x minus 2's in the denominator. So if I cancel one of them, it leaves me with an x minus 2 squared. And then if I simplify this expression here, x minus 2 plus 3, that becomes an x plus 1 in the numerator, and then I've got the x minus 2 squared still in the denominator. So look for those common factors that you can factor out, even if they look like expressions and not just numbers. So on number 6, we've got a fraction plus a fraction, or a rational expression plus a rational expression. In order to simplify that, we need to first add them together by getting a common denominator, and then see if we can factor and reduce. So my common denominator is going to be x minus 1 times x plus 2. In the numerator, this first fraction is missing the x plus 2. The second fraction is missing the x minus 1. So I'm going to multiply the 3 times x plus 2 for the first numerator and add to it x times x minus 1 from the second numerator. So now I don't see the same thing that I had over here again, where I can factor out a binomial. So I'm going to go ahead and distribute and simplify and see if then I can factor what I'm left with. So 3x plus 6 plus x squared minus x all over x minus 1 times x plus 2. I'm going to put this numerator in standard form, so x squared plus 2x, when I add these guys together, plus 6. all still over x minus 1 times x plus 2. And now when I try to factor this numerator, I find out that it won't factor. And so if it won't factor, then there's nothing that I can do to cancel. So this is going to be my final answer. I don't know that though until I get it all put into standard form and try to see if I can factor it. Alright, number 7 is the same type of problem as number 6, except for this time we're subtracting. We still need to get a common denominator, so I'm going to look at all the factors that are involved and find the denominator that includes all the factors of the current denominator. So the first one is x plus 1 times x minus 1. The second one is x plus 1 times x plus 1. So I need a denominator that has a combination of all those factors. So I need 2 of the x plus 1's, and then I need to add the x minus 1 to the mix. So x plus 1 squared times x minus 1 is going to be my common denominator. So now multiplying numerator and denominator by whatever factor was missing in the denominator, I'm going to need to multiply this first one by an x plus 1 over x plus 1. The second one I need to multiply by x minus 1 over x minus 1. So 1 times the x plus 1 is x plus 1 minus 2 times the x minus 1, so 2x minus 2. Now notice, I put the minus and then I added parentheses around the 2x minus 2. If you failed to put the parentheses around those two terms, you could end up with the wrong signs on that negative 2. So be very careful when you're subtracting that you subtract all of that, every bit of it. Alright, so now, just like we did on the last problem, I'm going to simplify the numerator. So x minus 2x is a negative x. 1 minus a negative 2 is positive 3. And now when I look at it in the numerator, all I've got is a negative x plus 3, which does not cancel with any of the factors that are in the denominator. So that's as far as I can go. Alright, number 8, get a common denominator again. So looking at the denominators for my first fraction, I've got x minus 6 and x plus 5. In the second fraction, all I have is an x minus 6. So notice the first fraction, that denominator has all the factors it needs, but the second fraction needs to add an x plus 5 to its denominator so that we have the common denominator, which is x minus 6 times x plus 5. So my 3x squared, I don't need to multiply times anything. Be careful with the minus, make sure you subtract everything. So I'm subtracting 3x plus 5 times x plus 5. So the first thing I need to do here is FOIL all this out and get it expanded. I'm still subtracting everything, so I still put it in parentheses. So 3x times x is 3x squared. Outside gives me 15x, inside's another 5, so that's 20x, and then last times last is 25. Don't leave your denominator out, keep writing it every single time. So now I'm going to distribute my negative sign here and simplify. So 3x squared minus 3x squared, so I lose the x squares. Distributing the negative the rest of the way, and I get negative 20x minus 25. And now I need to see what I can do about factoring the numerator. So I notice both terms don't have x's, but both terms are divisible by 5. So I'm going to factor the negative and the 5 out, which leaves me with a 4x plus 5 in the numerator. Still have x minus 6 and x plus 5 in the denominator. And once again, once you get everything factored and look at it, you'll see that there's nothing else that can be canceled and removed. So that is your final answer. So basically, the process you're going to follow to simplify these rational expressions is to get everything in factored form. If you've got multiple fractions, you need to get a common denominator and add them together, and then you can get your answer.